Okay, there's one problem that I want to make sure I go over. This is from a couple of previous night's homework here. This is page 10 for your packet. You guys finished this for homework, but I want to just specifically make sure I go over a limit problem in terms of how a limit problem can look on an AP exam FRQ. So this is page 10. Okay, so if we can go to part D here. Let's see if I can just run through these steps here. So if I want to do a limit problem, and it's an algebraic limit problem, what's the first thing that we do? All right, let's just see what's happening, right? We don't know exactly what's happening, so let's just replace every x with 2 just to get an idea, right? Maybe it's continuous, maybe there's a hole, maybe there's an asymptote. We don't know, so we're just at the beginning, we're just doing information gathering. Okay, so replace every x with 2. Okay, so now let's see if we can get this down to a number here. F prime of 2, what's F prime of 2? This is the F prime graph here. So what's F prime of 2 equal to? Yeah, it's just the y value, right? So F prime of 2 is 0. So e to the 2 minus 2, that's just e to the 0. E to the 0 is 1 minus 1 is 0. So this is something we call indeterminate form. So indeterminate form tells us that there's a hole in the graph, but the limit exists. We just haven't found it yet. Okay, it's not continuous. There's a hole, but even though there's a hole, the limit can exist because if you had a graph that looked like this, for instance, right? We know that the point doesn't exist, but the limit exists because if I pick points on either side of my target, they're both headed towards the same y value. So the limit does exist, but this is not one where we can, reduce and factor and reevaluate. This one, we really can't do anything to cancel anything out. So we have something called L'Hopital's rule, which allows us to use the concept of derivatives to help us to create a different version of this expression for us to evaluate the limit and hopefully get us to something that is a real number that we can use. So L'Hopital's rule says I can take the derivative of the numerator and the denominator separately and then evaluate again. So what's f prime's derivative? And then what's e to the x minus 2's derivative? Times 1. Good. E to the u times u prime. And then the minus 1 goes to a 0. Okay. So now that we have a different version of the expression. Now, normally we don't do this for derivatives, right? If I ask you to find the derivative of this, you have to go through quotient rule. But within the context of this problem, we're just using the derivative to help us arrive at limits. So this is not how we normally do derivative if we have a fraction, but we're doing this in service of finding limit, not because we're trying to find the derivative of the expression. Okay, so now replace every x with 2. So f double prime of 2, go to our graph here. F double prime of 2, but this is f prime graph. So f double prime of 2, we're going to find the what? The slope, right? And what's the slope of this line segment? 2, right? Up 2 over 1, slope is 2. And e to the 0 is 1, so 2 over 1 is 2. Now we have a real number, we can stop. That's our limit. Okay. I want to also make sure that that we understand the different variations of zero. Just because we see zero, it doesn't, they all can mean something different depending on the location of zero. So I want to kind of just do a run through of that. Let's say the limit ends up giving us something like 0/5. How do we interpret that? Is that a real number? Is that an indeterminate form? Is that undefined? Yeah, and what's that number? So that is 0. Okay, so this would be our real number. 0 over a non-zero would be a real number, which is 0. Okay, now what if it was limit as x approaches c of f of x of 10/0? This would be an asymptote. Therefore, we would say limit does not exist. Okay, because there's a vertical asymptote. But if you get 0/0, that means the limit does exist. There's a hole. We just haven't found it yet. We have to do more work to get to our answer. So depending on where the 0 is located, they all can mean something different. One's a real number, one, the limit doesn't exist, and then one, the limit does exist, we just haven't found it yet. And then something that AP College Board is picky about is when you're dealing with limits, if you're dealing with L'Hopital's rule, make sure you use arrows to progress through your problem, and only use an equal sign if you're absolutely convinced that both sides of the equal sign are exactly the same, because these are not exactly the same, and so use arrows to indicate that you're progressing to the next problem, but you're not committing to saying that they're the same thing. I wouldn't take off any points, but just to let you know, College Board are picky about that. So yeah, that's usually a good rule of thumb on true response questions. Use arrows as you progress. Try not to use equal sign, because if you see an equal sign, graders are told to look on both sides of the equal sign and actually look at it carefully and say, okay, are they actually equal to each other? If they're not, then they got to take off a point. Sometimes we don't use equal sign that way. We use equal sign to show that we're just showing the next step. We're not really saying they're equal to each other. So if that's the case, just use arrows. That way you're not going to get points taken off because both sides of your arrow is not the same value. Okay, so today we're just going to continue to work through these similar type problems. So we got through 14. Okay, so today we'll work through page 15 through 18. Seven, we have 7 to 10. Good. Yeah. I think you're caught up. Okay, so page 15. Let f and g be, or f and f prime are differentiable functions. Values of f and f prime are given in as like values of x. If g is equal to f of x quantity squared, find the instantaneous rate of change of f at x equals 9. All it's saying is find g prime of 9. Find the derivative at 9. Now, if you look at how this is set up, can you tell what is involved here if we want to find the derivative? Chain rule, right? There's an outside inside portion. If it helps, and I'm going to rewrite it using brackets. You don't have to. If you want to. So let's find the derivative here. G prime is equal to. All right. What's the outside function's derivative? The outside function is just that bracket squared. What's bracket squared's derivative? To bracket to the first power. Yep. Right. And do we just keep that, right? We don't do any changes to it. So that's the outside function's derivative times the inside function's derivative times f prime. Okay, so now we've applied chain rule. Okay, so outside's derivative, inside's derivative. Okay. Replace every x with 9 and then try to step by step get it down to a real number. Okay, so try that. And I'll work on it at the same time you guys do. Oh. Okay. Oh, yes. Let's just finish that. Show me in the class. Yeah, just show me in the class. Oh, you're looking on the 28th. I like 1 week down. We just pulled f of 9 and f prime of 9 from our table. So f of 9 is just equal to -2. F prime of 9 is just -4. Part C, k of x equals f of 3 of x times x squared plus 1. Find the slope of the tangent to the graph k of x at x equals 3. I want to find the derivative. It's the same thing, right? Instantaneous rate of change at 9. Find the slope of the line tangent at 3. They're both asking for us to find the derivative of the points, just different ways of saying it. Okay, so if I want to find the derivative, can you see what's involved here? What process is involved? If I want to find k prime. Product rule, yep. And there's something else though within product rule. The first term we're going to do a little bit of what? Yeah, a little bit of chain. Yeah. Okay, so I'm going to set that up. Okay, so let's figure out what the derivative of this will be. So what is f of 3x going to turn into? You said chain rule. So how does chain rule look with f of 3x? Anything else?
Times 3.
Times 3 times inside function derivative. Good.
X squared plus 1.
Yeah, and now, now I feel more familiar. Okay, so see if you can, guys can finish the rest, and I'll work on it at the same time. Okay, part D. We saw this, something similar to this. We got to take the antiderivative. This is in function notation. Ultimately, what's f double prime going to turn into after we make it go through antiderivative process? It turns to f prime. And then, but there's a 3x here. We got to go through a little bit of what? U substitution, yeah. And their u value is just whatever is inside the parentheses there. Okay. So we'll go through u substitution, get it in terms of u, take the antiderivative, bring our x back in, keep track of our coefficient, and then we can plug in our upper and lower bound, and then we can use the table to help us get it down to a number. Okay, so work on that, and I'll do the same. Mm-hmm.
I could put a 9 instead of a thing.
Oh, so once I found my antiderivative here, I got to bring my x back in. So otherwise, if I try to evaluate at this stage, then there's a mismatch in variable. So I started with x. My bounds are in terms of x. So easiest way to do is bring in terms of x, and I plug my upper bound in. So 3 into x, 3 times 3 is 9. Okay, part H, page 16. Let n of x equal to the integral from 0 to x squared of f prime. So evaluate n of 3. So let me do that first, and then we can worry about the derivative later. So we'll do n of 3. N of 3, we can just follow whatever the rule tells us. So from 0 to what? 9. 3 squared is 9, yeah. Okay, we can evaluate this using first theorem. There's no need for u substitution because there's nothing but an x inside here. So what's the integral of f prime going to turn into? It's going to rise up to what? F prime will rise up to. Yep, and then we can plug in the upper lower bound, right? So f of x, and then plug in upper lower bound, f of 9 minus what? F of 0, yeah. So this is just first theorem, right? Make it go through the antiderivative step, and then the upper bound minus lower bound. Okay, before we can find n prime of 3, we should find what first? X, yep. So let's find the derivative first. So look at how this is set up here. What does that remind you of? I want to find the derivative of this mess. This is what? It's going to happen here. Yeah, second theorem, right? So let me put second theorem here just so we can kind of match up our steps here. The operations will cancel out, but the upper bound will have some residual effects on our answer or on our derivative. So let's do that. So n prime is equal to. All right, so what the rule says is these operations cancel out, but I'm going to plug the upper bound into the function. So what would that look like? close f prime of x squared, right? So we're not going to change this function. Whatever we see, we're just going to leave it. Normally, we would go make it turn into something else, but because we know derivative integral will cancel each other out, we're not going to make any drastic changes to the function. We're just going to make that upper bound inserted into the variable. So it's going to be f prime of x squared. But that x squared will produce something else, right? So times what? Times 2x. So that is the derivative of this expression. Okay, so now it's a lot easier. Replace every x with 3 and then using the table to get it down to a number. Okay, next up, q of x is natural log of f of x. Find q prime of 5. So to find q prime of x, I need to find the derivative here. As a reminder, this is natural log of f of x, but let me remind us here. What's the derivative rule for natural log of u? U prime over u. Okay, so let's follow that rule here. So what do you think natural log of f of x is going to turn into? F prime over f of x. Replace every x with 5. Okay, part K. Let r of x equals f of natural log of x. I want to find r prime. Right? What's involved here? This is chain. Yeah. Do you see that outside inside portion? We got to the outside portion before we get to the inside portion. Right. What's the outside portion's derivative? F prime of. Yeah, so we're not going to change anything there, right? And the natural log of x's derivative, what's natural log of x's derivative? 1 over x, yeah. That's my inside portion's derivative. Okay, what's natural log of 1? 0. F prime of 0 is okay, let's keep going. Page 17. Yeah. Yeah, okay. Okay, so we have a graph of f of x. We see a semicircle, we see a triangle, and we want to kind of lightly shade in. We just understand that ultimately anything that is involving the area of the graph, we're just looking at this region here, even though you may see other shapes. Those shapes are not part of the problem. It's just the semicircle, the triangle, and the triangle. So next part, part A, AB number 1 says find G of 2, G prime of 2, and G double prime of 2. Why don't we just go ahead and build the G prime and G double prime so that we just have that in front of us and we can just jump directly into evaluating. So I'm going to just take the space up here just so we can kind of build out each of our functions that we're going to need. So if I want to find G prime, this reminds us of what? Second theorem, right? We know this is going to cancel each other out. So let's walk through this here. We know this cancels out. This becomes what? F of times 2x. Sorry. It doesn't, because normally it would, because if it was just the integral, it would. But the derivative and integral, they're going to cancel each other out. So that f of t is not going to change much because we're doing something and then we're undoing it. So ultimately, those calculus processes will just cancel each other out, leaving that function not changing much. Now this gets a little messy here. If I want to find G double prime, guess what I have to do to get the G double prime? These are being multiplied. So what's process is needed if I want to find the derivative of this expression? Product rule and a little bit of chain. Yeah. So we got to, that 2x is kind of messing things up here. It's making that derivative process a little bit harder to go through, but yeah, let's go ahead and build that out so we just have that in front of us. Okay, so we'll do f prime g plus fg prime. Okay, what's the derivative of f of x squared? You said chain rule, right? So what does chain rule look like for this problem? Okay, so that's the full f prime. Now to the g function. Back to f. And x squared. And then g prime is 2. Yeah. All right, so we got all the messiness out of the way. Now it's going to be a lot more straightforward. We can just plug 2 into each of the respective formulas and then get it down to a number. Okay, so let's see if we can finish part. Let's see if number 1, and then we can stop. And the rest you guys can do for homework. So this simply is just adding the area that we see between the graph and the x-axis, the shaded region. Anything above is positive, below is going to be a negative. My semicircle is 1/2 pi r squared. What's the radius of my semicircle? 2, right? What's f4 equal to? 0, yeah. How can I find f prime of 4? That's the what of a slope. So what's the slope of the f graph for? What's the slope of this line segment? -2, yeah, down 2/1, -2, yeah.
It's double priming.
I'm sorry?
It's double.
Oh, sorry, yeah, G double prime thing. Yes, thank you. Okay, your homework is to finish up to page 18.
So, it was like, I think a version, and it was like with the leaves, and I wasn't paying attention, and I like never fit on the first one. So I like write it all, but it's at the point. So it's the first page, it's like, okay, yeah, so.
How much?
Is left. Just think we're gonna cut the name, I'll get more here.
Okay.
I'll see if you're full of them. We're not gonna say different names, we'll just finish. Let's get back tomorrow.
Okay, that's awesome. Okay, appreciate it. Yeah, the other interest spot. Okay. Thank you.
Which one you was it, you left the. They take micro last.
Like four girls.
Do you think micro, do you think micro last? Thank you.
No, I didn't.
That's fine. You know, a lot of people from like micro that we say trying to take.
Yeah, I've literally asked like 5 separate people.
Yeah.
And I can't find anybody.
Sorry about that.
Oh, that's all good.